Last episode, state was the agent's memory, reducers the right heat map, who wrote what, but a graph that only ever walks a straight line isn't an agent yet. This episode you teach the graph to decide. One node looks at the state and chooses where to go next. And because that choice is a pure function, the decision reproduces perfectly. Here's the straight line graph you have today. Start into a classify node, into one fixed node, into end, one path. No matter what the input is, the graph walks the same way. It can't react. To react, it needs a fork. So you add a fork. Classify no longer points at one node. It points at a router. The router is a function. It takes the state, reads one key, and returns a string, the name of the next node. Add conditional edges wires that string to a real node. 3 possible strings, 3 branches, math, lookup, chat. Watch run A. The input is a calculation. Classify writes route ponders math into state. The router reads that key, returns math. The graph lights the math branch, amber, and the other two stay dark. The taken path is the bold one. Now run B. Different input, a fact question. Same graph, same router, same code. Classify writes route, lookup. The router returns lookup. The graph lights the lookup branch instead. Nothing was rolled. The branch is a deduction from state, not a dice throw. That's the whole point. The router is state to name. No randomness, no model sampling inside the edge. So if you replay the same state, you walk the same branch. 2 inputs, 2 branches, both fully determined, which is exactly why both of them reproduce. Here's the program. We import the harness, build a state graph with a classify node and 3 worker nodes, and wire classify to a router with add conditional edges. The seeded model says which class the input is. That's the only fake part. The state is a dict with input, route, and answer. Classify calls the scripted LLM, gets back a class word, and writes it to root. Pure function of the script. No parsing tricks, no regex on a real model. This is the router, pick branch. It takes the state, reads state, route, and returns it as the next node name. That returned string is the edge. Add conditional edges maps each possible return value to a node. Each worker node runs a scripted tool over the in-memory world and writes answer. The math node calls calc, the lookup node calls search, the chat node just echoes. Every tool is a pure function, no network, no disk. We compile, then invoke twice with 2 different inputs. Run A is a calc, run B is a fact lookup. We print the route each one took, and the branch counts the trace recorded. Then the discipline, reproduce runs each invocation twice in process, and asserts the traces are byte identical. Assert identity checks the figure's headline number equals the terminal's branch count equals the headline. Same trace draws the figure. Routing is a pure function of state. That's why a mocked branch reproduces to the digit. You've built a graph that decides once and walks. Next, let it decide again and again. The cycle, react as a graph that loops back on itself.